This is the second half of a practice quiz. So if you didn't watch the first video yet, go ahead and click the link in the upper right hand corner and watch 1 through 8 first. In this video we will practice finding the derivative using the product rule and the quotient rule, and also we will use the derivative to find equations of tangent lines. For the next few problems we're just finding the derivative. For problem number 9, I want to rewrite it first before I try to find the derivative. So I'm going to take the x to the 7th power that's in the denominator, and I'm going to move it out of the denominator. So I will have 2x to the negative 7 power plus 4x cosecant x. Now I'm ready to find the derivative. So for this first term, I'm going to do the power rule. Negative 7 times 2, so that's negative 14x. I reduce this power by 1, so that's to the negative 8 power, plus. Okay, this is going to be the product rule. So for my first time through here, I'm going to take the derivative of the first factor, and I'm going to leave the second factor alone. So the derivative of 4x is 4, and I leave the second factor the way it is, cosecant x. This is the product rule. And then I do a plus, and then I come at it a second time. But the second time through, I leave the first factor alone, and I take the derivative of the second factor. So leaving the first factor alone, I'm just going to have my 4x, and now I'm going to take the derivative of the second factor. In my mind I'm thinking the derivative of secant is secant tangent. So the derivative of cosecant is negative cosecant cotangent. So that's what's happening now, times negative cosecant cotangent. We don't need to simplify anything on this page, so we could just leave our answer like this. Ooh, number 10, time for the quotient rule. I think of this as a poem and not a song because I don't usually sing it, but this is the quotient rule in poem form. When I say d high or d low, I'm talking about the derivative. So low d high less high d low. Draw the line, and down below, the bottom squared will go. This is the quotient rule. Now, what do I mean by this? Y prime equals low d high. So when I say low, I'm talking about the bottom part of this fraction. So low is simply x to the 4th power minus 8. And then d high. So we have to do the derivative of the top part of the function right now. So the derivative of x to the 3rd power is 3x squared. The derivative of sine is cosine. So that is low d high. Low d high less high d low. Less means subtraction. So low d high less high. So high means just write down the top part the way it is. So x to the 3rd power plus sine x. And then d low. D low means take the derivative of the bottom part. So power rule, this will be 4x cubed, and that's it, since the derivative of a constant is 0. So right now we have low d high less high d low. Draw the line, and down below, the bottom squared will go. So we just put the bottom squared. I don't know why I left all this room. I guess I was ready to simplify a bunch of stuff, but I just remembered that on this page we don't have to simplify anything. So that's it. we're done. I'm going to rewrite this a tiny bit before I take the derivative. So y equals cotangent x plus 4x to the negative 1 power. I just brought this out of the denominator. Now I will find the derivative y prime. So what's the derivative of cotangent? Well, I first learned the derivative of tangent is secant squared. So the derivative of cotangent is negative cosecant squared. So here I go, negative cosecant squared x. Moving on, power rule. Negative 1 times 4 is negative 4. Reduce this power by 1, so we have the negative 2 power. And we don't have to simplify anything on this page, so that can be our answer. For number 12, I'm going to rewrite this a little bit before I take any derivatives. So the square root of x is the same thing as x to the 1/2 power. The cube root of x is the same as x to the 1/3 power. Now I will do the derivative, y prime, power rule. Put the 1/2 in front. Reduce this by 1. If I subtract 2 over 2, that's going to be negative 1/2. So I have negative 1/2 plus. Power rule again, put that 1/3 in the front. Subtract 1. So I'm subtracting 3 over 3. So that's negative 2/3. Negative 2/3. I see this extra comment for number 12. Your final answer should have no negative exponents. So basically there's a tiny amount of simplifying that we do need to do. So anywhere I see a negative exponent, I'm going to drop that particular expression down to the denominator. So here I go. I have y prime equals. So here's my 1/2. But I'm dropping this x to the negative 1/2 power down. And I'm going to make it x to the positive 1/2 power. And I'll do the same thing right here. There's my 1/3. If I drop this down, I've got x to the positive 2/3 power in the denominator. So according to the rules of engagement, I can leave my answer like this. But you know what? As long as they have me simplifying stuff, I might as well show you one more thing I might do if this were a multiple choice question or something. Fractional powers are in the form power over root. So 1/2 power is the same thing as the square root. So I might write this as y prime is equal to 1 over 2 times the square root of x plus 1 over 3 times. So now I'm looking at this one. The 3 in the denominator is the root. So that makes this the cube root of something. The 2 in the numerator is the power. So I could write this as the cube root of x squared. So this is another form of the answer. By the way, when you do this cube root of x squared business, this is just a side note. The cube root of x squared is the same thing as the cube root of x, and then all of that is squared. So in other words, it doesn't matter if the exponent is under the radical or outside the whole thing. So if you're doing a multiple choice question, it could be in either place, under here or outside here. So just be aware of that. For function f, the equation of the tangent line at x equals 2 is 5x plus 112. Before I even read anything else, as soon as they say the tangent line, I'm interested in the slope. So if this is the tangent line, then y equals mx plus b tells me that this is the slope. So let's write down a little side note. Function f, for function f, the slope is equal to 5 at x equals 2. Let's read on. For function g, the equation of the tangent line at x equals 2 is this. Same story, because of y equals mx plus b, we know that the slope of this tangent line is 5. Okay, so let's write that down. So function g, for function g, the slope is again equal to 5 at x equals 2. Well, this is a calculus class, so how can I translate these statements into derivatives? Let's get some calculus going. So for function f, if the slope is 5 at x equals 2, we're talking about the derivative, all right? The derivative, f prime, tells you the slope. So f prime at 2 is equal to 5. Similarly, for function g, if the slope is 5 at x equals 2, that means that the derivative, g prime, is 5 at x equals 2. So both of these statements are true. So now let's look at our multiple choice. Which of the following must be true? F prime minus g prime is equal to 29, don't know about that. F at 2 is equal to g at 2, don't know about that. Look at this one right here. F prime at 2 equals g prime at 2. Yeah, check it out. F prime at 2 is equal to 5. G prime at 2 also equal to 5. So yeah, F prime at 2 is equal to G prime at 2. The answer is C. Number 14 says, find the equation of the line tangent to the graph of y equals sine x minus cosine x at the point 0, 1. You may give your answer in any form. When they ask me for the equation of a line, I'm always going to write that equation in point-slope form, which looks like this. In order to write point-slope form, we need two things, a point and the slope. A cool thing about this problem is that they've already given us a point. The point of tangency is 0, 1. All we need is the slope. Well, in a calculus class, the way you find the slope is you find the derivative. That will give you the slope at any point, including this one. So the derivative of this function, taken one term at a time, the derivative of sine is cosine. And then the derivative of cosine is negative sine. But minus a negative is addition, so I'm just going to have cosine plus sine. So this is the derivative. So now we need to find the slope using the derivative. They gave us the point 0, 1, but we just need the x value to find the slope. So the x value is 0. So we're finding the slope at x equals 0 using this derivative formula. So I'm just going to say that the slope at x equals 0 is going to equal cosine 0 plus sine 0. Whoops, I knew I was going to do that. 0 is over here on the unit circle. This is the point 1, 0. Cosine is the x value, sine is the y value. So that means the slope at x equals 0 is going to be 1 plus 0. The cosine of 0 is 1 and the sine of 0 is 0. Therefore, the slope at x equals 0 is 1. So we just found the missing piece that we needed to write this equation. We had the point from the very beginning, and now we know that the slope is 1. If you have the point and the slope, you can write the equation of the tangent line. Using the point-slope form. So I'm going to say y minus y1. So y minus 1 is equal to the slope, which is 1, times x minus x1. So this would be a perfectly acceptable equation of the tangent line. I don't feel like putting a 1 here or a 0 here because those are not necessary. So I am going to take this one extra step and write y minus 1 is equal to x. So this would be better to me. I'm biased, I guess. But you might even add 1 to both sides. I mean, we're right there. So y equals x plus 1. So any of these three equations would be acceptable. So I think I'll put boxes around all of them to show that I have respect for all three versions of the answer. But wait, it's not over. Number 15 connects back to this. Which of the following is equivalent to the linear equation you wrote above? No work is needed. So I see in all of these forms we have x and y on the left, and then we have the constant on the right. So if I were to take any of these versions, let's look at this last one just as an example. If I were to take this and subtract x from both sides, this would give me y minus x. Well, you know what? They're putting the x's in the front, aren't they? So let me write it that way. If I subtract x from both sides, I would have negative x plus y is equal to 1. So is that one of the choices? No, all of the x's are positive. So I'm going to divide everything by negative 1 or multiply by negative 1, whatever you want to call it. So that would make this x minus y is equal to negative 1. This is going to match one of those answers. So let's see. X minus y is equal to negative 1 is answer choice C. Number 16. The line y equals negative 2x plus 3 is tangent to the graph of y equals kx squared, where k is an unknown constant. Find the value of k. Here's a visual of what we're talking about. If we pick the k value right, then this red function is going to have this green line as a tangent line. I want you to focus on the point of tangency, because this is the intersection between the line and the curve. So two things will happen at this point of tangency. For one thing, both curves will have the same slope. And let's write that down. What is the common slope at the point of tangency? Slope slope has an e in it. Well, y equals mx plus b. The slope of the line is negative 2. So that means at the point of tangency, the slope of this parabola is also negative 2. And because this is an intersection point between the line and the curve, we also know that this is a point at which the line and the curve will be equal. First, let's deal with the information that the slope is equal to negative 2. All right, the slope of this curve has to equal negative 2. Well, when we talk about the slope of a curve, we're talking about the derivative. So let's go ahead and find that derivative. Y prime we're doing the power rule. So the 2 is going to come in the front, and we're going to have 2kx. All right, because we reduced the power by 1. So this is the slope of the curve at any x value. But we already know that the slope should equal 2. So that means that 2kx, all right, which is a formula for the slope, at the point of tangency, this should equal -2. Ultimately, our job is to figure out what k is. We're looking for k. So let's go ahead and solve for k right now. We'll get an expression for it. So I'm going to divide both sides by 2, and that's going to give me kx is equal to -1. Now I am going to divide both sides by x, and that is going to give me k is equal to -1 over x. All right, file this away for later use. We're going to need this information in the future. Now it's time to go back and use the other piece of information we spoke of. Remember, at the point of tangency, the line and the curve intersect. So at the point of tangency, these two equations should be equal in value. So let's set them equal to each other and find out where that x value is. So let's see, -2x plus 3 should equal kx squared. But we just found an expression for k. So in order to be able to solve the equation I just wrote down, we need to go ahead and put in the expression for k. So this is going to be -2x plus 3 is equal to -1 over x times x squared. This should be solvable. Let's keep going. Well, the x cancels out one of these x's, so I end up with -x. Let's add 2x to both sides. So that's going to give us 3 is equal to x. Okay, file this away for a second. So we now know that x is equal to 3. What were we trying to find? We're trying to solve for k. We have an expression for k. We just found out what x is. What if we go ahead and plug this x in right here? That's it. K is equal to -1/3. Last problem. If the line tangent to y equals f of x at point -3, 8 passes through the point -2, 5, then which one of these statements is true? I feel like I can make this more obvious by adding in one word, and that word is also. If the tangent line passes through the point -3, 8, and it also passes through the point -2, 5, then we have 2 points that are on this line. We should be able to easily find the slope of the tangent line, because that's y2 minus y1 over x2 minus x1. So here we go. I'm going to do 8 minus 5. Okay, let's call that y2 minus y1. And -3 minus -2. So that's -3 plus 2. So the slope of my tangent line is going to be 3 over -1. So that's -3. So this is the slope of the tangent line. In fact, I'm going to stick it over here. But that means the slope of the curve at this point is also -3, all right? The slope of the tangent line is the same thing as the slope of f of x at this point. But the slope of f of x is f prime, all right? The derivative is the slope of a curve at a point. Focus on the x value. We're talking about the slope of the curve at -3. So the slope of the curve at -3 is equal to -3, the same as the slope of the tangent line. So I'm really hunting for this expression right here. Do we see it? It is choice D. The slope of the curve at -3 is -3.